Today I am going to discuss about normalization. What is meant by normalization? Why we can go for the normalization? Normalization is a process of decomposition into smaller relation. Is nothing but normalization. Why you can go for the normalization? The given database is a good database or bad database. Good database or bad database. Okay, what is meant by good database? What is meant by bad database? Suppose the given database is good database, no problem. The given database is a bad database, that's why we can go for the normalization. Is a process of decomposition into smaller relation. Okay, what is meant by bad database? That is a redundancy. Redundancy. Redundancy means repetition of duplication data. Okay, that is a normalization is a technique to remove redundancy. Okay, and then here observe here, first one is a student table. This is the row level duplication, row level, and then this is a column level duplication, column level duplication. What is here? Redundancy. One is a row level duplication, second one is a column level duplication. Observe here row level duplication, I mean 1 Sita 15, I mean 1 Sita 15, that is a twice. That is a row level duplication. That's why how we can eliminate the row level duplication? By using normalization technique. That is a, we said that is a student ID is a primary key. Student ID is a primary key. That's why that is a we omit the one record or one row. That is a row level duplication. How it can eliminate? By using primary key. That is a SID is a primary key. That's why we won't allow duplication. 1 Sita, I mean 15, 2 Rama 25. That is a row level duplication. Okay, and then before set the primary key, it is a bad database, and then we said that is a SID is a primary key, it is a good database. Whereas the second example, second one is a table name also same, that is a student table. Table name is a student table having student ID, student name, course ID, course name, faculty ID, faculty name, salary. Observe here, what is that here? Is there any, here SID is a primary key. SID is a primary key. Is there any row level duplication? No. 1 Rama C1 DBMS F1 John 4000. Is there any one? Rama here there is a 2 Ravi C2. Is there any 2 Ravi C2? No, there is no row level duplication in second table. Observe here there is a column level duplication is there. That is a C1 DBMS F1 John 40,000. C1 DBMS F1 John 40,000. And then here C1 DBMS F1 John 40,000. This is a column level duplications is there. Clear? That's why the given database is a bad database. That's why you can go for the normalization. By using normalization to decompose into smaller relations. How you can eliminate? And what are the drawbacks in bad database design? What are the drawbacks? Drawbacks in bad database design. Bad database design. What are the drawbacks in bad database design? What is the first drawback is the insertion anomaly. Insertion anomaly. Second one is a deletion anomaly. Deletion anomaly. And third one is a updation anomaly. That is a 3 problems. Anomaly means problem. Insertion problem, deletion problem, updation problem. What is here? Bad database design. How you can say that? Observe here insertion. First one is a insertion problem. Suppose if you want insert, that is a Raju. Name is the Raju. And then course is the, that is a C10, Java. We introduce the new course. Okay, we introduce the C10, Java. Observe here, what is the introduce the course. Is there any empty here? No. Why? Because this SID is a primary key. That's why we won't insert the, in our table. That is a problem, insertion problem. Why? Because that is a C10 Java is a new course, but what about students? There is no students here. Okay, that is a problem. That is a insertion problem. Second one, deletion problem. Observe here, deletion. Suppose if you want delete particular row, that is a, what is a, by using SQL, and what is a command? Delete from table name student, delete from student, where SID equal to 2, and suppose if we delete the second row, that is the data can be removed. But what about if you delete the record, particular record, and what about that is a faculty and then course? Okay, what about remaining students suffers from problem? That is a drawback in, that is a deletion problem. Suppose if you want delete the second record, what is the problem here? That is a course name is Java is there, some faculty can be also deleted. That is the problem. That is a deletion problem. And whereas in the updation, suppose if you want update salary, that is a 40,000 to 50,000, 40,000 to 50,000. What is that syntax? What is the command? That is a update table name, that is a student, set salary equal to 50,000, salary equal to 50,000, salary equal to 50,000, where CID equal to 1. Observe here that suppose if you want update the salary, what is that here? 3 times C1, 3 times can be updated. That is a updation problem. What is the insertion problem? A deletion problem, updation problem. This is the drawbacks in bad database design. How can say that the given database is a good database or bad database? Good database means there is no redundancy. Redundancy means a repetition of duplication of data. Okay, these are row level redundancy, column level redundancy. In row level redundancy, observe here 1 theta 15, 1 theta 15. That is the 2 rows are same. That's why we remove, that is a duplication of data by using normalization technique. By using, that is a SID is a primary key. Okay, whereas in the column level duplication, what are the problems in column level duplication? One is the insertion problem, a deletion problem, and then updation problem. Deletion problem, insertion problem, updation problem. That is the good database and then bad database. That's why you can go for the normalization. Normalization is a process of decomposition into smaller relations. There are different types of techniques in normalization. First normal form, second normal form, third normal form, BCNF, fourth normal form, fifth normal form. That is how we will see one by one. What is meant by first normal form? What is meant by second normal form? What is meant by third normal form? What is meant by biscore normal form? Fourth normal form and then fifth normal form. Okay, I hope you everything is able to understand what is meant by normalization. Why we can go for the normalization? Normalization is a technique to remove a redundancy. That is a row level and then column level redundancy. Row level is the, observe here, that is the 1 theta 15, 1 theta 15. That's why we eliminate by using primary key. We said SID is a primary key. Okay, that is a good database. Whereas the second one is a column level redundancy. C1 DBMS F1 John 40,000. C1 DBMS F1 John 40,000. C1 DBMS F1 John 40,000. For suppose you want update the salary, that is at 3 times. That is the drawbacks in bad database design. Okay, and then that's why you can go for the normalization technique. Here normalization technique, before going to the first normal form and then second normal form, first what is meant by functional dependency? What is meant by functional dependency? Functional dependency is nothing but x tends to y. X tends to y. Y is dependent on x. Y is subset or equal to x. Is nothing but functional dependency. X is a determinant. X is what? A determinant. Y is dependent. Y is dependent. That is the x tends to y, y subset or equal to x. that is the x is the determinant, y is dependent. What is the property of functional dependency? T1 of x equal to T2 of x. Then T1 of y equal to T2 of y. That is the property of functional dependency. Okay, before going to the first normal form, second normal form, first what is meant by functional dependency? What are the property of functional dependency? Observe here, that is a first example, example 1. There is a student ID and then student name. Student ID is the 1, 2, S name is the Ranjit and then Ranjit. Functional dependency is satisfied or not? What is according to our definition? X tends to y. X tends to y. X must and should is a key. X must and should key, that is a super key or primary key, whatever it may be. X tends to y, X compulsory key, y may or may not be key. That's why first example, is it functional dependency valid? Student ID tends to student name. And what is it here? 1 Ranjit, 2 Ranjit. That is a functional dependency is valid. Functional dependence is valid. Why? Because SID tends to S name. SID tends to S name. According to functional dependency property, SID is a key. That is X tends to y, X compulsory key, y may or may not be, y duplication is there. Okay, that is the functional dependency is valid. Second case, what is the second case? Second example, SID, S name, that is a 1 Ranjit, 1 Ranjit. Observe here, based on the property, that is a T1 of, T1 of 1 equal to T2 of 1. T1 of, T1 of Ranjit equal to, T2 of Ranjit. What is the based on the property? T1 of x equal to T2 of x. What is the here? T1 and T2 are the tuples. T1 and T2 are the tuples. X and y are the attributes. X and y are the attributes. Observe here, T1 of x equal to 1, T2 of x equal to 1. The condition is satisfied. T1 of x equal to T2 of x. Then T1 of y equal to T2 of y. T1 of y equal to T2 of y, that the name is the Ranjit. That's why functional dependency is valid. Functional dependency is valid. First case and then second case valid. And what about there is a third case? Observe here third one. 1 Ranjit and then 1 Kiran. What is the SID is the first one is a 1. S name is a Ranjit. 1 Kiran. Based on the property. What is the property? SID compulsory must and should key. But here duplication is there. 1 Ranjit and 1 Kiran. That's why this is not valid in functional dependency. Based on the property. Whereas the fourth one, observe here 1 Ranjit and then 2 Kiran. Based on a functional dependency x tends to y, x compulsory key, okay, no problem. 1 determines Ranjit, 2 determines Kiran. That is a functional dependency is valid. Whereas the third case is a functional dependency is not valid. Not valid. Why? Because here SID tends to S name. SID is a key. But what is a here? 1, 1 same. That is a here what about right hand side? Ranjit and Kiran. But according to our functional dependency property, x compulsory key. But here 1, 1 duplication occurs. That's why this is not valid case. Okay, that is a functional dependency. And the next one more example, that is a fifth one, SID, course ID, FID. Observe here, what about SID tends to CID, functional dependency valid. CID tends to FID, functional dependency valid. CID, FID tends to SID, functional dependency is valid. To check, first one is the SID tends to CID. What is the SID tends to CID? Simply we can write as SID, CID. What is the SID is the S1, C1, second one S1, C2, third one S2, C1, S2, C1. Observe here, what is the here? S1, C1, S1, C2, S2, C1. Observe here, based on the property, is it valid or not? SID tends to CID and then CID tends to FID. CID, FID tends to SID. Okay, what is the first case? First case is the SID tends to S1, C1. Okay, S1, C2, S2, C1, no problem. Functional dependency is valid. And whereas in the second case, what is the second case? CID tends to FID. CID tends to FID. What is the C1, F1, C2, F2, C1, F1. What is the C1, F1? C1, F1, you write one time. That is a C1, F1. Second case, that is a C2, F2. That is a functional dependency is valid. Functional dependency is valid. Third case, CID, FID tends to SID. What is the CID, FID tends to C1, F1, tends to S1, C2, F2 tends to F1, okay, and then C1, F1 tends to S2. That is a functional dependency is, that is a, case is not valid. Why? Because here C1, F1, that is a duplication is there, and whereas in the right hand side is a different techniques. This is a functional dependency. What is meant by functional dependency? X tends to Y. X determines Y. Y is dependent on X. Okay. That is the, based on the functional dependency. And then before going to the functional dependency, what is meant by closure? Closure is nothing but the set of all the attributes that are functionally determined by an attribute set. Observe here closure. What is meant by closure? Suppose R of A comma B comma C relation. A tends to B. B tends to C. C tends to D. C tends to D. What is meant by closure? A closure. A closure. Closure is nothing but, according to our definition, the set of all the attributes that are functionally determined an attribute set. A closure. A derives what? B. B derives what? C. C derives what? D. A derives what? A, B, C, D. We can get the, relation here also, relation of R of A, B, C, D, we can get the original relation. And what is that? Once again, I will explain. That is a R of A comma B comma C comma D. That is a tends to B. B tends to C. C tends to D. And what is that? A closure. A closure means simply we can write as A. A derives what? B. B derives what? A tends to B, and then B tends to C. C tends to D. We can get the original relation. That's why A closure, that is a is a key. A is a key. That is a super key or primary key, whatever it may be. Okay, is it clear? That is the closure definition. And then whereas in the observe here, gate 1999 bit, that is a R of A comma B comma C comma D comma F be a relation scheme with the following dependencies. Functional dependency FD equal to C tends to F, E tends to A, EC tends to D, A tends to B. Which of the following key for R? Which of the following key for R? That is based on the functional dependency technique. Okay, I think you are familiar with that. And what is the key for R? What is meant by key? I think based on the closure. Okay, closure, what is the closure? Once again I will explain. R of A, B, C, A comma B comma C. That is a functional dependency. A tends to B, suppose B tends to C. And what is meant by A closure? What is meant by A closure? A closure nothing but simply we can write as A derives what? B, B derives what? C. We can get the original relation. Yes, we can get the original relation. That's why A is a key or super key or candidate key. Clear? Suppose B closure. B closure. What is a B closure? BC. We can't get the original relation, only BC. That is a can be missed. That's why B is not a key. Suppose C closure. C closure. What is a C closure? C. C is not a key. C closure. C is not a key. Why? Because C closure only C, but we miss A and B. That's why here A is a key. That is a primary key or super key or candidate key. Okay. What is meant by super key? Super key is nothing but an attribute or set of attribute that has uniqueness property is nothing but super key. Okay. And what is my super key here? Example R of A comma B comma C. That is A tends to B and then B tends to C. C, A tends to B, B tends to C, and then A tends to B and then B tends to C. What is a closure? That is a closure. A closure means AB, right? A is a super key. Suppose AB closure, A, B and then C. Why? Because first one observe here A closure. A derives what? B. B derives what? C. Next AB closure combination. Simply we can add as AB. B derives what? C. That's why we can get the original relation. AB is a super key. ABC closure. ABC closure. Simply we can add as ABC. That is A derives B. B derives C. Okay, that's why A and then AB and then ABC. A comma AB comma ABC is a super key. This is a super key. But according to our example, what is the question is the candidate key. What is which of the following key for R? Which of the following key for R? First we find that is a key. What is the first one key? C closure. That is a C closure. What is a C closure? CF. What is a F derives? There is no only C and F. Why? Because C closer, simply we can add as C and then we can get the F. Is there any F? F derives? No. That's why based on the reverse engineering we apply, that is the first one, A answer. That is a CD closer. CD closer. What is a CD? Simply we can add as CD. What is a C derives what? F. C derives F. What is F? No. That's why this is not a key. And the next one B. EC closer. EC closer. What is a E? And then C. Observe here, what is a C? C is a C derives what? F. I mean E derives what? A. I mean EC derives what? D. I mean A derives what? B. Observe here, what is a, we can get, what is a D is there, that is a D is there. I mean A is there, okay, right, A is there, and then D is there. I mean next one B is there, and next one C is there. I mean E is there, F is there. We can get the original relation. That's why EC is a key. What about remaining two examples? Suppose observe here, AE closer. AE closer. What is the AE closer? AE. AE. What is AE? That is a E derives what? A. A is there. I mean, what is EA? I mean AE. AE. No. A means that is how we can derive B. A derives B. Right combination, is there any combination? I mean B derives what? No B. And then E, already A is there. I mean A, that is a B is there. That is not key. That's why the given answer is a, I mean EC. That is a second option is a correct option. That is a based on the technique. What is the technique? Simple technique, closer. We know closer, we can easily identify the, I mean keys based on the closer technique. Is it clear that the let R A comma B comma C comma D comma E comma F be a relation scheme with the following dependencies? These are the dependencies, means functional dependencies. What is the functional dependencies? X tends to Y. Y is depend on X. Clear? What is the key for R? Key. How can find key? Based on the closer. In reverse engineering, we apply AC closer, AE closer, and then EC closer, CD closer. I mean last one, AC closer also is there. AC closer. What is the AC closer? AC. Simply we can add as AC. A derives what? A derives B. A derives B. And then what is the C derives what? F. C derives what? F. And then next one, EC. Is there EC? No. No EC. That's why we cannot get the original relation A, C, B, F. But original relation is a B, C, D, E, F. We cannot get the original relation. That's why only answer is the EC. Okay, na? That is the, I mean, functional dependency property. That is the first question. I mean, next one is a, I mean, GATE 2005. GATE 2005. That is a consider a relation scheme R equal to A comma B comma C comma D comma E comma H on which of the following functional dependency hold. That is a given A tends to B, BC tends to D, I mean E tends to C, D tends to A. What are the candidate keys of R? What is meant by candidate key? Candidate key is nothing but the set of all the relations in the key. The set of all the keys in a relation is nothing but candidate key, or minimal super key is called candidate key. Okay, observe here the same example, that is a, I mean R of A comma, I mean B comma C comma D. That is a tends to B, I mean B tends to C, I mean C tends to D. A tends to B, B tends to C, C tends to D. And what is the first one is the A closer, closer definition, A closer. I mean A derives what? B, B derives C, C derives D. And then AB closer, we can get the A, B, C, D. I mean ABC closer, we can get the A, B, C, D. I mean A, B, C, D closer, we can get the original relation A, B, C, D. Here A, B, ABC, ABCD are the super keys, but among all four, that is A is a key. A is a key. But based on the technique, what is here? The candidate keys. What is by candidate key? The set of all the keys in a relation is nothing but candidate key. Observe here, what is the same closer definition? We find AE closer and then BE closer. What is AE closer? AE closer. AE closer. What is AE? Simply we can write as AE. What is the A derives what? B. I mean next, is there any E? E derives what? C. E derives what? C. And then next one BC. BC derives what? D. BC derives what? D. Right? What is the A is there, B is there, C is there, D is there, E is there. But according to our definition, A, B, C, D, E is there. But there is no H here. That's why this is not correct. This is not correct answer. AE close. Why? Because one answer is wrong. That's why totally wrong. That is second case. AE same. You cannot get the answer. C1 AEH closer. AEH closer. AEH closer. That is a AEH. AEH. What is A derives B? Right, no problem. That is E derives what? C. Okay, BC derives what? D. D derives A. Already A is there. That's why A is there. B is there. C is there. D there. And then E is there. H there. That is we can get the original relation. That's why first option okay. AEH okay. And what about that is the next BH? That is a BEH closer. BEH closer. That is a BEH. BEH. What is a B? B. E tends to what? C. That is a EC. And what is the next one? And D. There is no D here. That's why C is not correct answer. A is not correct. B is not correct. C is not correct. And what about third? Last option. AEH closer. AEH closer. Already. You can get the answer. That is a AEH. AEH BCD. Okay. And then next second one is a BH. BH closer. What is a BEH? What is B? What is E? E tends to C. What is a BC derived what? That is a D. What is a D derives what? A. Right, correct one. A, B, C, D, E, H. Third one, DH closer. DH closer. DH closer. And what is here? D, E, H. What is a D derives what? Is there any D? That is a A. You can get the A. D derives A. A derives what? That is a B. A derives B. And then what is the next one? E derives what? C. You can get the original relation. That's why the correct option is the D. Okay, that is a consider relation schema or A of B, A comma B comma C comma D comma E comma H, and that is the candidate key. The set of all the keys in a relation is nothing but candidate key. Candidate key. Okay, that is what is meant by normalization. Why we can go for the normalization? What are the drawbacks in normalization? What are the three drawbacks? One is the insertion problem, second one is the deletion problem, third one is the updation problem. That's why you can go for the normalization. Normalization is a decomposition of smaller relation. Observe here, this is a column level problem. That's why you can decompose into smaller relation. What are the smaller relation? First case, that is a SID, CID. That is one relation. Second one is the course ID. Second case course, second one, second table, that is SID, S name. First R1 relation is the SID, S name. Why? Because column level duplication is there. That's why you can decompose into smaller relation. This is the relation R1. R2 relation, separate table, that is a CID, C name, CID, C name, that is one relation. R3 relation, that is a FID, F name, salary. This is one relation, R1, R2, R3. It can decompose into three smaller relation. Why you can decomposition? This is a column level duplication. That's why you can go for the normalization. Suppose if you want to add any course ID, no problem. If you want to update any salary item, no problem. That's why decomposition to smaller relation. Okay, today we will stop here. In next class, what is meant by first normal form, that we will see in the next class. Thank you.